Assalamualaikum and good day to everyone. We are from Section 01 Group 5 Engineering Fluids Mechanic Lab are about to present our Lab 5, which is related to Pelton wheel turbine. My name is Muhammad Aslam Zulkarnain, my metric number is M019303 and I am from Kuantan, Pahang. First, let's see into the background of Pelton turbines. The man behind the invention of Pelton turbines is Lester Allen Pelton, an American inventor who was born on September 1829. He is the father of hydroelectric energy power and he is the guy who invented the first Pelton wheel or Pelton turbine. In the late 1870, Pelton invented his water wheel because coal mines need additional power source to run machineries and mills. In 1883, the Pelton turbine won a competition for the most efficient water wheel turbine. And later in 1888, Lester founded the Pelton Water Wheel Company to begin industrial production of his revolutionary water turbine. Generally, Pelton turbine is a sort of free jet water turbine which is used to generate hydroelectric electricity. It is the one of the first green technologies taking the advantage of the use of the kinetic energy of flowing water to replace wood and coal. Figure here show the component available on the Pelton turbine. Some of the advantages of these turbines are that they are simple to maintain, has no cavitation problems, has a basic structure that is easy to install, can perform at a high height and low discharge as well as has a high overall efficiency. The problem statement of this lab is the increasing need for power supply from humans around the world has led to an increased interest in generating electricity from various sources, and one of it is by using a flowing water. Therefore, the investigation into the source of power supply from Pelton turbines need to be carried out by techniques of an experiments. If the headwater and flow rate are known, it is easier for us to identify the ideal size of Pelton wheel to be utilized, how quickly it should rotate to achieve the maximum efficiency, and how much power it should produce can be calculated. The objective of this lab is, first, to determine and evaluate the Pelton wheel turbine's efficiency and performance under various operating conditions. Second is to gain a complete understanding of the structure and operation of a Pelton turbine. Third is to examine the relationship between Pelton turbine's power output, curve of torque, and efficiency. Fourth is to determine the maximum power at various nozzle setups by plotting the Pelton turbine power curve. And lastly, to develop and assess a full fluid flow measuring technique and experimental process for Pelton turbines. For the lab scopes, we will be focused on examining and learning about the characteristic and working principle of Pelton turbine for fully open and power curve by using a lab scale setup. The maximum torque and efficiency of the turbine and the maximum power output will be calculated, and a graph displaying the connection between those values and the Pelton wheel's RPM will be drawn. Furthermore, we will look into the effects of adjusting the nozzle position on the amount of power produced and identify which position generates the least amount of power.
My name is Abdul Hamdi. Today I'm going to present you the theory part of Lab 5 Pelton wheel turbine. So moving to the next slide. The Pelton turbine is a turbine which operates at a head of above 300 meters. Is a turbine capable of performing under significant potential head of water. The runners are made of circular disc which is semi-cups called buckets equally distributed around their circumference. One or even more nozzles are positioned so that each jet travels along tangent to the circular path which runs through the center of the buckets. So going to the next slide, which is all the parts for the turbine, the jet, the buckets, the nozzle, the casing, every part is very essential to the procedure. So now going for the operation, you can see in the figure 2. It shows that the layout of hydropower generating the plant can help explain the operation. A benchtop and Pelton turbine nozzle follow high-speed water storage. As the water moves through it, it gains kinetic energy, so it can be electric. To cool off the runners, the nozzle's water jet is just striking the buckets. Because of this, the spear inside the nozzle controls how much water gets to the veins or buckets and how fast it rotates. So, the Pelton wheel turbine head types. There is two types: the gross head and the net effective head. So, The difference between the water level in the reservoir, and the water level in the tolerance energy is a symbol. It's a symbol. The net of the effective the net of effective head is the head of accessible at the turbine's outlet, and the symbol is H. And here's the formula. So types of efficiency in the Pelton water turbine. There's the hydraulic, the mechanical, the volumetric, and the overall efficiencies. So in explanation, it's described as the proportion of energy generated by runners to the power divided by the jet turbine's entry. And you can see this is the equation for it. And if you want to measure the mechanical efficiency, it is described as the proportion of power gained from the turbine's shaft to the energy generated by the runners. You can see this is the equation for the mechanical efficiency. The overall efficiency is described as the proportion the turbine shaft generated power to the water jet generated power. So it's the power accessible at the turbine shaft overall efficiency, power accessible from the water jet, and the volumetric efficiency is described as the proportion of volume of water striking the runners to the volume of water delivered to the turbine by the jet. So you can see from this equation, that's the volumetric efficiency equation. So the formulas of Pelton wheel. There are so many formulas evaluating the Pelton wheels. You can see this. There's the frequency, refrigeration, the power, the heated head, the below equations from the force. Going for the next slide. Here's the list of formulas regarding to the previous slide. There is the flow, the speed, the peripheral, the formulas, and the calculation of the power. The flow ratio formula is the flow velocity ratio is that to the energy at the inlet. You can see from the equation. And the speed ratio, it is defined as what? As the peripheral velocity ratio to its energy head at the inlet. And the second one, the peripheral velocity, the velocity at the inlet U1 of the Pelton wheel is equal to the velocity at the outlet U2. The calculation of power, the power P, whereas you can see from the equation of the formula, the power is P, and the angle velocity of the wheel. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Rahmati Yusuf and my matrix number is M019196. I live in Machang, Kelantan. Today I'm going to present about chapter 3, which is method and procedure. First is equipment and apparatus. In this experiment we use Pelton turbine HM150.19 demonstration Pelton turbine. Next is hydraulic bench HM150, and lastly is handheld technometer to measure the speed. We move to next is method and procedure. Firstly is before proceeding to the experiment, all the connection of the water are checked so there has no leakage in the hydraulic bench. The spray valve is completely closed. Turn in fully clockwise and make sure the storage tank is full of water. The experiment starts with turning the hydraulic bench and gradually open the control valve while opening the speed controller until the bench flow is at the maximum and the spray valve is fully open. The hydraulic bench is used to measure the initial flow reference. The inlet pressure is recorded. The water from storage tank will be pumped outflow to measure tank level to measure rate of the speed of the nozzle. Next is the technometer is used to measure the maximum rotation. The technometer is put against the clear glass at the back of turbine and used to detect the reflection sticker on the drum. The average rotation speed is estimated over the course of a few seconds. The volumetric flow rate is determined by plugging the drain at the bottom of the bench with the drain column. The waterline on the side of the bench is observed. The timer is started when the waterline reaches 0 liter and it stops when it reaches 10 liter. The volumetric flow is obtained by dividing the 10 liters. The experiment is repeated by reducing the RPM. That's all for me. Thank you.
Hello and good day everyone and to our beloved lecturer. Meet myself, I'm Dina, metric number MA19218. Now we're about to see the chapter 4 which is the results, graph and discussion for the lab Pelton wheel turbine. So let us discuss further about it. So in this section we're about to cover the data calculations. So the first part is the characteristic curve, as you can see in the table uh, as follows. So the values were situated was the rotational speed, the braking force, the moment of the shaft, the power of the shaft, and also for the turbine type we have hydra power, and also the efficiency of the turbine, and also the efficiency without the shaft seal ring on it. So to obtain some values in the table 4.1 for the characteristic curve, we had used some equations in order to calculate the hydraulic power, which is the power of the hydra, and the efficiency of the turbine, and also followed by the efficiency of the turbine without shaft and seal ring, as you can see, which I was stated in the slide. So in this next section, we're about to refer the power curve. So the table 4.2 shows the power curve results through the calculations which were given by the lecturer itself. So in the table, we're about to see the estimation of the braking force starting point 0.5 Newton till followed by 6 Newton, and also the rotational speed and also the power on the shaft. Okay, now we're about to witness the plots and discussions for this lab 5. So the first question is regarding about the graph torque versus RPM. So this is the calculated measurement that we have obtained for the torque versus the RPM results. So based on the table, we had plot a torque versus RPM graph. So we, based on the graph, we were able to say that the as the rotational speed of the Pelton turbine decreases, the movement of the shaft, which is known as the torque, will increases. So the trend of the graph line can be stated as that the two quantities are nearly directly proportional. So we can say that the plot values may have some tolerances which may reduces the accuracy of getting a perfect plot. So the next question is about the graph power output versus its RPM. So as you can see, the table shows the rotational speed and the power on the shaft. So based on the values, we had generated a figure which shows the plot of power output versus RPM. So based on the graph that we have obtained, we were able to say the power output increases and decreases at the end as the rotational speed decreases. So the plot trend shows an increase in curvature and later it decreases in curvature as well. So the power output reached a maximum point and was maintained at a particular RPM range level before decreasing. Okay, now let us refer to the third question. What is the maximum torque produced? At 286 RPM value, the Pelton turbine produced at a maximum torque of 0.1325 Newton meter. So the torque is maximal when when the runner is stopped. So when the runner speed is equal to the initial jet velocity, the torque will be zero. So the fourth question, what is the maximum power output from the shaft with the constant nozzle? So based on the results obtained, at 470 RPM value, the Pelton wheel turbine produced the maximum output from the shaft with a constant nozzle of 3.2 watt. So what is the efficiency of the turbine? So the jet must strike the exact middle of each Pelton bucket. So as previously indicated in the bucket design, the jet provides and optimum propulsion to each bucket. Since the rotation of the turbine depends on the velocity of the water jet, the efficiency of this experiment is calculated using a formula which is known as P out divided by P in. Thus, the efficiency of the turbine is dependent on its power output. So, a Pelton turbine can achieve at 95% efficiency. So, however, the average efficiency will be measured from this experiment is 0.83%. So, in the last question, what is the maximum power of the turbine can produce? So, based on the calculation at 474 RPM value, the turbine produces a maximum power of 5.60 watt. So, the higher the power input, the lower the power output will be. So, the power output depends on the power input of the turbine wheel. So, I think that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Nufail and my ID number is M019138. As for now, I'm going to present to you the last chapter for this project, which is the conclusion. So what did we manage to achieve? So we managed to determine and evaluate the Pelton wheel turbine's efficiency and performance under various operating conditions. We also managed to gain a complete understanding of the structure and operation of a Pelton turbine. Then we also managed to examine the relationship between the Pelton turbine's power output, torque, curve, and efficiency. Next, we managed to determine the maximum power at various nozzle setups by plotting the Pelton turbine power curve. And lastly, we managed to develop and assess a complete fluid flow measuring technique and experimental process for the Pelton turbine. So what is the general conclusion for this experiment? As a result of the experiment conducted, we can conclude that the performance of a Pelton wheel turbine is affected by a range of flow rates and rotating speeds. The jet velocity affects the input power or work and determines the output work measured in watts. The higher the input power from the nozzle jet, the higher the flow rates, but the lower the output power. Therefore, we require the optimal combination of the two. Impulse turbines are typically high head, low flow device. Consequently, we can conclude that our experiment was a success based on our collected results. So these are the references used in order to make this experiment successful. Thank you.